Hello everybody. For this video, we're going to talk about the midterm review. I'm going to do half of the problem, and you can try to follow my work to do the other half, just for some practice uh, in preparing for the midterm. I'm not going to say all the words out loud. I will just say the key phrase, and then you can hopefully follow my steps from here. Okay, starting from number 1a, the first thing we are going to do is to do our distribution. And then we're going to combine like terms. And add 6x both sides, plus 2 to both sides. We're going to get 10 equals to 26, 10x divided by 10 on both sides. X equals to 26 over 10. And if you simplify that top and bottom by 2, you get 13 over 5. Double check the answers. Should be good. Moving on to the next problem then. For C, this kind of quadratic, you can use the quadratic formula, or you can factor. Here, this is a pretty easy thing to factor, so let's just do that. Set this equals 0. And then set that equals 0. And you have our two answers here. Moving on to the next problem. This one too, you can definitely try to factor, or if not, you can use the quadratic formula. Let's go ahead and try to factor here real quick. Just factor by guess and check. Looks like this is the right factor. We can double check. Right, these two add up to be this number right here. Anyways, so that means we got 3x minus 5 equal to 0, right? Set that one equal to 0. Plus 5 divided by 3. Similarly, set the other term equal to 0, factor equal to 0, plus 2. And that's your two answers right here. But again, you can choose to use quadratic formula, or you can go ahead and factor. Moving on to this part, the easiest way is to go ahead and multiply the entire thing by the common denominator, which in this case is this thing right here. We're going to go ahead and distribute. And there's some cancellation when I distribute here. The x plus 1 cancel, so we got 4 plus 2. Similarly, when I distribute to the second term, x plus 2 cancel, so x plus 1 here. And then on the right hand side is just x plus 1, x plus 2. Then I can distribute. Same thing here. And then the right hand side I FOIL. Combine like terms. Same thing on the right hand side. Bring everything over to one side, so minus x minus 5. I'll get 0 equals to x squared plus 2x minus 3. And again, this is a pretty easy thing to factor, so let's go ahead and do that. Theta equal to 0. This one. Theta equal to 0. And we are done with this kind of problem. Moving on to the next one then. For radical functions, you have to bring everything without radical to the other side. So I'm going to plus 8, or minus 8 rather, to both sides. So the function becomes and now I square both sides. The square gets rid of the square root and that negative, so I just have x minus 2. Right hand side, I still have to FOIL. I'll leave that to you if you don't remember the formula. And again, bring everything to one side. So we get 0 equals to x squared minus 17x plus 66. Again, very easy to factor here. Z is equal to 0, you get x equals to 11. Theta equals 0, you get x equals to 6. Now these are not your answer just yet, you have to double check, right, in case any one of these are extraneous. So for x equals to 6, we plug it back into the original equation. So we got 8 minus square root of 6 minus 2 equals to 6. So I guess 8 minus square root of 4 equals to 6. And square root of 4, of course, is 2. So 8 minus 2 equals to 6. And that's good. Let's check for 11. We're going to get 8 minus square root of 11 minus 2 equals to 11. But then that's just 8 minus square root of 9 equals 11. 8 minus 3 equals to 11. Well, clearly that doesn't work. So 11 is an extraneous solution. Therefore, x equals to 6 is the only solution for this problem. Alright, moving on then. For number 2, you're given two functions and then you're asked a bunch of combination of functions. The first four here is just basically definition. So, for example, f plus g of x, that's just another way of saying f of x plus g of x. And we know exactly what these are, so just go ahead and write them out. 3x squared plus x plus square root of x plus 1. And really the rest is very, very similar. So, for example, for b here, it would just be 3x squared plus x minus square root of x plus 1, right, etc. And the more interesting part is e and f. We're talking about composition of functions here, right? So f of g of x, That's just another way of writing f of g of x like this. That means whenever I see x in f of x, I now plug in a g. So 3 g of x squared plus g of x. I know what g of x is, so 3 square root of x plus 1 squared plus square root of x plus 1. And square root and square cancels out. We got 3 times x plus 1 plus radical x plus 1. The most you can do at this point is to distribute the 3. So that's your final answer. Now for f, you can, plug in the number 8 directly into this equation right here, the one we solved previously. But in case you did not have to do that first, then this is by definition f of g of 8. So what we can do is simply evaluate g of 8 first. So f of g is square root of x plus 1, so g of 8 is square root of 8 plus 1 is equal to f of square root of 9 is equal to f of 3. Now we apply f by plugging in 3. So we got 3 squared plus 3. All the 3's there. Check that real quick. Okay. The answer here is 3 times 3 times 3, that's 27, plus 3, the answer is 30. Okay, so there's just two ways of plugging in numbers into composition functions, depending on whether you knew the explicit formula for the composition or when you don't. Either way is fine. Moving on then to inequalities. Okay, again for 3a, we're gonna distribute. Okay, combine like terms. Not changing the sign because I don't need to at this point. This step also doesn't require me to change the sign. Addition and subtraction never changes the sign. Now I divide by -1. I do need to change the sign. So that is my answer, but now I need to write this in the interval notation. So x is bigger than -8, so the -8 is the smallest thing. So it has to look like this. -8. And then it can go as big as infinity. I'm using the parentheses because it is a strict inequality. Okay, going on to the next problem. For double inequality or triple inequality, whatever you do to one side, you do to all three sides. So once you have that rule, nothing else is different here. So -2 on both sides, or all three sides. -3 less than 3x then 6. And then we divide 3 on all three sides. -1 less than equal to x less than 2. And now again, the smaller number on the left, bigger number on the right. And smaller number, the -1 bracket, because it's equality, the equality with the inequality, and then the two open parentheses because it is strict inequality. So that's it for the inequality problems. For the zeros of the function, this is just another way of saying setting the function equal to 0. So all you have to do is set the function you're working with into 0. And here, if the number is super big for you to guess, with factoring, go ahead and just apply quadratic formula. It's not too bad, especially you have the aid of calculators. But this one, surprisingly, is okay to guess, just because the 7 is also easy to factor. But the factor here is this is the factor. You can double check this real quick. But once you factor, it's just a easy, simple setting things equal to 0. 3x minus 1 equal to 0. And then the 6 is equal to 0. Okay, so that's it for this kind of problem. Now for this one, for part B, I just want to quickly mention that you don't have to deal with the whole thing, right? A fraction for a rational function is equal to 0 if the numerator is equal to 0. So all you have to do is set the top equal to 0 and solve for it that way. Okay, just a quick reminder. So basically, you only have to solve for this. Okay, and once again, it becomes a easy factor or quadratic formula problem. Moving on to number 5, equation of lines. This is kind of important, so make sure you practice that a little bit. So for this one, if you're given 2 points, label them. And then apply the slope formula. Slope formula is y2 minus y1 over x2 minus x1. So plugging the functions, the numbers, we got 7 minus -4 all over 3 minus -2. And you're going to get 11 over 5. And then from here, choose any point you'd like to work with, and then apply point slope form. So I already have this x1 and y1 labeled, so let's just use that. So y minus and x minus -2. And we get y plus 4 equals to 11 over 5. X, make sure you distribute this, plus 22 over 5. They just minus the 4 on both sides. But to minus the 4, I need to make common denominator, so multiply that by 5 over 5. And then from here, we can have y equals to 11 over 5x. And then I have 22 over 5 minus 4 times 5 is 20. 22 minus 20 is 2 over 5. So that right there is my final answer. Part C, you're given a point and already given the slope out loud, so you just directly jump into the point slope form, and you should be good to go. So basically, y minus 1 equals to 3 over 4, x minus 2, and then you clean up from there, right? Turn into the slope intercept form. Same thing with D and E. All you have to do is be able to extract the slope information. Parallel lines have the same slope, so the slope I'm working with is just that. So m equals to 1 over 4. Hit it with the point slope form, we get y minus 1 equals to 1 over 4 x minus negative 3. And then again, I'll leave the cleaning up to you. Similarly to parallel, perpendicular lines have a certain format, right? The slope is opposite and reciprocal. So m here is the opposite and reciprocal of this number, so negative 3 over 5. And again, the point slope form that, and you can simplify from here, or clean up from here. Moving on to the next problem then. Find the inverse function of the following. This is that, the 3.5 steps problem that we're dealing with. So the first thing here is to replace, I guess step 0 as I call it, is to replace f of x with y. And then step number 1 is to switch position for x and y. And 2 is to solve for y. So I go ahead and subtract 5 on both sides. Divide by 4. Take the cube root on both sides. And then plus 1 on both sides. Just right on top. We got cube root of x minus 5 over 4 plus 1 equals to y. And then I guess step 3 is, all I have to do is change that y to f inverse. So f inverse of x just rewrite that real quick. So slanted. Oh well. But that's your final answer, and those are the steps. Moving on to number 7 then, long division. Now these are not too bad of a problem, you just have to remember the steps. Here we go. We're going to go ahead and set these up. But for this one, we see that we got 3x squared minus 1. We're missing that middle term, so we want to put a placeholder. That way we have our correct format. So looking at the first term, I needed an x squared, so I distribute, and then I'm going to subtract result. I get negative 6x cubed. That should be cubed right here. Plus 12x. 11 minus negative 1. Back down to 2x. Now it looks like I need negative 2x. Multiply, distribute. Numbers. We square there. Oh, okay. Subtraction here. We got 12x squared plus 0x. And then drag down to negative 4. So it looks like I need 4. I have 12x squared plus 0x minus 4. Wait. Looks like the remainder is 0. And my answer is just up here. Yeah, I can just highlight this. Okay, well, not too bad of a problem for long division. The last problem type is for synthetic division. This one's actually quicker. So the setup here is you just write the coefficient of the dividend, and then in this box you put whatever makes this equal to 0. So negative 1/2. So the first thing we do, we copy down the 6. Negative 1/2 times 6. Negative 3. We're going to add this time. Negative 11 plus negative 3 is negative 14. Times the negative 1/2 give me 7. Negative 19 plus 7 is negative 12. 1/2 times negative 12 is positive 6. Negative 6 plus positive 6 equals to 0. So my remainder is 0. And the way you incorporate that is you lose 1 power per each column. So at this point, we just have 6x squared minus 14x minus 12. That's your final answer. Okay. So that's it for just kind of problems, and that is it for this um, portion of the midterm review. You do need the final review to have a comprehensive review of the entire thing that's going to show up on the final. So take a look at the other video, or at least the solution for the other one as well.